Hi, my name is Addison, and today we're talking about calorimetry. Calorimetry is a technique used to measure the changes in temperature, such as heat, from the energy produced by a reaction, something like this. And this can be important in everyday life, like to control our metabolic rates in our bodies, and that helps maintain homeostasis, which is essential. And this relates to calories, like in the food labels of everything that we eat and drink every single day. Okay, so a little bit more on how calorimetry works. So in this experiment, you would use 2 styrofoam cups, the ones that look like this, but I don't have any of those, so I'm just gonna demonstrate with solo cups. So you're gonna wanna have 2 of them, and you have 2 so that it insulates like the reaction, and so there's not any heat like lost or gained or whatever that doesn't have to do with what is going on in the reaction, because you want the results to be as accurate and precise as possible. So you use 2 and a lid to ensure that no heat escapes. So you start with one of your substances in the cup, and then you add in the other one, and it's helpful to have like a stir in the bottom so that it can kind of just, mix everything, and to make sure that like the temperature isn't like going up and down as the like reactants are like reacting with each other. And once you have them both in there with the stir, you put the lid on it, and you have your thermometer in there as well, and make sure it does not touch the bottom of the cups. You just want it in the solution or whatever you're measuring, and this should be the only open spot where the probe goes, and everything else should be pretty much sealed again so that heat doesn't escape. You're gonna want to record the temperature every 5 seconds for 4 minutes straight, just so you can make sure that you get the initial temperature and also the ending temperature, and you make sure that you do not miss anything that happens in the middle, and so that you don't stop like measuring the temperature prematurely before the reaction is done. Okay, so a few tips and tricks for calorimetry would be to, when you're handling chemicals, make sure to handle them with care. Wear protective attire like goggles and gloves, and just make sure that you're being really careful because some of these can harm you. Make sure to do your research beforehand. Also make sure you're wearing appropriate clothes, closed-toed shoes, a lab coat, all of the essentials to keep you safe. Remember that when you are doing the experiment and you're measuring the temperature of the surroundings, not the system. And the system is what you are looking for. So say you have an increase in temperature, that would be the system losing heat and giving it to the surroundings. So that would be an exothermic reaction because the system would be releasing heat to the surroundings, and that's why you get the temperature increase. But the system would actually be decreasing. The temperature of the system would actually be decreasing, and vice versa. So if the surroundings has a loss of heat and the temperature decreases, that means the system is taking in that heat, which would make the reaction endothermic. And then lastly, equilibrium is when the temperature of the system as well as the surroundings are the same consistently. And this is another reason why you measure the temperature for 4 minutes straight, so you can make sure that the reaction is actually at equilibrium before you stop measuring the temperature, so you can make sure you get all of the data points exactly how it's supposed to be in the most accurate and precise way possible.